Kish.
Are we good?
Yeah.
So, do you want to start or should I just jump in?
I'll start. Okay. So, good afternoon, everyone. Thank you all for joining us today for what promises to be an insightful and engaging event. I'd like to start by introducing you to our amazing Azure developer community on Tamil Nadu chapter. And our community is a passionate group of developers and IT professionals. And recently, there have been also students who are being part of our community. Our mission is to foster a supportive environment where members and can stay up to date with the latest Azure development best practices and trends. Today's event is another step in our ongoing journey to bring valuable content and networking opportunities to our work. So I'll also take some time to appreciate our volunteers and the organizing committee who made the event possible today. So it's my great pleasure to introduce today's speaker, Ahmed Muhi. Ahmed is an Auckland-based cloud consultant with a deep-rooted background as a network architect. So he also specializes in Azure solutions, and he has an experience of over 15 years, where he has been passionate for learning new skills and being up to date with all the technologies. So today, Ahmed will be talking to us about design thinking in the cloud, architecting Azure workloads. So I encourage everyone to participate actively in today's session. Feel free to ask any questions and share your thoughts in the chat, and we'll address them during our Q&A session. So the stage is all yours, Ahmed. You can go ahead.
Thank you so much. Thank you so much, Kishore, mate. Thank you. Appreciate it. And hey, everyone. Welcome to the Azure community, the Azure developer community of Tamil Nadu. So as Kishore said, I'm Ahmed. I'm a Microsoft MVP, a cloud solution architect. I also write on my blog on iamax.com. I have got a YouTube channel at iamax as well. And I write on Twitter with the handle of Ahmed Muhi 01. So today I will be talking to you about design thinking in Azure and how do we apply that using the Azure Well-Architected framework for any workload that we want to build on Microsoft Azure. So before I start and talk about the new Microsoft Well-Architected framework, I wanted to introduce you first to the idea of design thinking. So what is design thinking? So as a developer, you are tasked with creating an application, right? And then that application, like there is some business requirement, there is some technical requirement. So design thinking was built. It's a framework for you to help you build your application with the trying to guarantee the most successful, most innovative solutions, right? Design thinking is based on human-centric approach. The idea is that when you want to solve the problem, it's all about the user. It's all about it's all about the developer, the stakeholders, the platform team that's going to maintain your application. So that's why it's human-centric. And design thinking is also an iterative process. So what do we mean by that is that the design thinking, as it's been defined, it got 5 phases. Phase 1, which is the empathize, the define, ideate, prototype, and then test. So what do we mean by all these phases? The empathize is basically putting yourself into the place of the user. So like trying to understand all the requirement of the user, understanding the business requirement, really empathizing with the user, understanding what is the intended outcome, right? And the next step is for you to start and then build the define the problem. So clearly state the problem. What is the problem? User is saying, as we'll see later on, for example, your business wants to build an e-commerce website, right? and it gives you like a set of requirements, and then you go through these requirements, clearly define it as the next step. The third step, which where you start to ideate, this is where you start to brainstorm. So you just build as much possible, as much feasible ideas, and you don't care a lot about how successful or like how possible is the idea. You just start to build you start to build a lot of ideas, and then you worry about the good ideas, the most appealing one, in the next phase. And the next phase, which is the prototype, this is where you start to quickly create a prototype of a solution to the problem that you have defined earlier. And then the prototype should not be something very complex, should not be something very expensive. It should be like a simple idea. You create like the high-level idea of, okay, so this is what I want to build. The user is asking me for this and that. So you just put it into some sort of a framework, and then you start to prototype your idea. And then quickly build that idea, and in this case on Microsoft Azure, you build the idea so that you would have something to test. And that leads us to the last phase, which is the testing. Testing is where you got this prototype, and you start to go back to your user. In this case, it could be the business, could be the business employees. It could be even your customers when if it's an e-commerce website. You start to test the product. So that process, the whole design thinking, it's designed to quickly iterate between these phases so that you will end up with a prototype that would help you test it, and then collect enough feedback, and then go back again to define what is required if you need to change it, right? And the last thing to notice here is that you need, when you build this prototype, you need to balance desirability, which means what the user want, feasibility, which means how technically feasible is this idea, is it possible to achieve, and then viability, which here we're talking about the technical viability. What we mean here is that is it cost effective to actually run this prototype, right? The next step here, where we start to talk about design thinking meets Azure well-architected framework, right? So in the previous slide, we talked about quickly iterating through your user requirement, defining the requirement, building ideating, building a prototype, and then testing. How does that translate into building your application on Microsoft Azure? So when you build your application on Microsoft Azure, you start by understanding the requirement, designing a solution, implementing that solution on Microsoft Azure, test and gather the feedback, so test your solution, and then finally refine it, optimize it, and then iterate back again to the requirement. So it's a very simple way of thinking about a difficult problem that might become complex if you don't start with this process, which is a user asking you, which could be, as we said, it could be a business or like a user for an idea of an application. So you start to iterate on that and then build it using the design thinking, but also you connect it back to the well-architected framework. And then again, with the idea of design thinking, since it is human-centric, the connecting that back to the well-architected framework, which we'll talk about in a second, you see that those users, or what we call actually stakeholders in this time, they're tightly connected to those pillars of the well-architected framework. So, for example, we've got the user, which normally users always care about how the performance of your application. So if they want to go to a website, they want it to be performant, they want it to be usable, of course. But the most important thing for us building the platform is that you need the application to be performant. For your developers of course care about the cost effective, care about the security of the application, care about the operational side of it, but of course they care that the main care is that their application is reliable. What by reliable means like increasing the availability of your application, so they try to avoid having downtime. And for operation teams, they care about operation excellence. So things like automating manual tasks, having some sort of monitoring. This is important for operation team to make their lives easier. And of course, for the business, is the main two concerns is that this solution needs to be cost efficient and also needs to be secure. So the cloud empowers and help us to rapidly iterate on these ideas, test them, and then the Microsoft Azure Well-Architected Framework helps us translate those ideas into solutions and making sure that these solutions follow the best practices and industry standards, making sure that these applications are performant, reliable, operationally excellent, and then cost-effective and secure, right? So now we'll start with our example application. So what I want to do here, we just talked here about the idea of design thinking, and now we want to put ourselves in the place of a developer who's been asked by their business or by their user, someone coming your way, approaching you, saying like, "Can you help me build an e-commerce website?" So you start to understand the user requirement, you start to empathize with the user, and they collect all the requirement that the user is telling you about. And then after you understand all this, you get all this requirement, you turn it to clearly defined requirement that you need to build up to. So in this case, this is the business requirement. So what the business is telling you, they want an online store. They wanted to support 100,000, so they expect that they have 100,000 monthly active users. They want to, of course, want it to be secure, 99.9 uptime. They wanted to, and they wanted to have the ability to handle seasonal traffic spikes. So what that means that they wanted to be scalable. What the idea of scalable is that, so if the load increase on the system will not crumble. The system would scale in what we call either horizontally or vertically. Horizontally means if you have one instance of your web app and then you get more demand, you will have more instances. And then vertically means if you have one instance of your app and then the demand increase, you get more CPU, more memory. So that means that the system is scalable and it can handle seasonal traffic. And then seasonal traffic, say like there is a specific, let's say school holidays, and then people jump into their website, buy a lot of products, and then that increases the traffic only in a specific period, let's say in 2 weeks during the school holidays. But after that, the traffic slows down and then you need to scale down. So that's what means by handling seasonal traffic. And of course, it needs to be easy to manage. Of course, it has like a product catalog integrated into the system inventory. And then, of course, needs to be budget conscious. So this is just to give you an idea of what type of business requirement that you might get when you are trying to build an application and how to use the design thinking and the Azure Well-Architected Framework to do that. So now we talked about the technical requirement. This is where you start with your knowledge, with your experience to actually understand and translate what the user and the business were telling you to build. So the business were telling you all about things that they understand, how much users they will have, the spike in the seasonal traffic spike, being secure, being easily maintained. And then you start to build on the well-architected framework, which has 5 pillars, as we can see here: the security, the reliability, performance efficiency, cost optimization, and then operational excellence. And then based on your understanding of the technology and your understanding of the well-architected framework, you start to take these pillars one by one. And in this case, we'll take, for example, the security. So you'd say, okay, I need to implement authentication authorization, make sure that these people are entitled to access this service, or like if they buy something that they have enough credit or and so on. You need to encrypt data, you need to ensure it's PCI compliance, Reliability means that you need to increase the uptime. You need to have, as we said, the auto scaling. You need to have a disaster recovery. Increase the performance. So, for example, you need to optimize your database so that it will have better performance. You need to implement some sort of a caching system again. So, like when you have access to a specific data, common access, so you can put it in a caching system. That this way, you would have easy access to it. You don't have to retrieve it from the database every time. And again, content delivery network. Again, very similar concept. So a user open up your website and it contains a lot of static content that is served every time a new user is visiting your e-commerce site. So you put it in the CDN network so that it will be easily accessible. And of course, that's cost optimization. You need to have like appropriate costing. You need to have auto scaling so that it will not cost you a lot of money all the time. You need to monitor and then always optimize the resource usage. So if a resource is not always being used, maybe you downsize it. Maybe you even shut it down if this resource is no longer used because it's costing you money. And finally, for operational excellence, this is where you start to say like, okay, so I need to make sure that I have proper login, proper monitoring. I need to always automate manual and tasks that are repetitive so that I will save myself time, increase the consistency, and also avoid the human mistakes. And then, of course, have a procedural operational procedure. So like have some sort of runbooks or playbooks behind the scenes to understand how to maintain the environment or like how to like introduce new features into your application. And again, as you could see here, we started design thinking. We started with the the business requirement. With our understanding, we translated that into the framework that Microsoft created for us. And then based on this framework, we have actually started to address or to build a really solid solution for our prototype here. And you're starting to see the value of the well-architected framework because it helps you make sure that you have really addressed all the concerns for building an application in a well-architected manner, and it's also following best practices. And now we'll start to actually begin to introduce ourselves to the well-architected framework. So what is the well-architected framework? So well-architected framework is a set of guidance, recommendation, best practices that Microsoft created for building all sorts of workloads from all their like hundreds of thousands of customers from like experience from multiple countries, multiple organization dealing with public sector, with private sector. It's really comprehensive and it caters to all these needs. And what Microsoft did recently in November 2023 is that they restructured this well-architected framework so that it will be consistent, will be easier to navigate, and it's also made sure that it is more developer-centric. So the idea is that it will focus more on design, less on implementation, and then also, as we'll see later on, when I'll visit the well-architected framework, Microsoft Azure documentation, and we'll see how it is consistent and how it gives us a lot of guidance here. So what changed in the new structure? So in the new structure, Microsoft, in every pillar, Microsoft made sure that to have 4 to 5 core sections in every single pillar, right? So these sections are the design principles, the design review checklist, the trade-offs, the recommendation guides, and then, of course, the cloud design patterns. So what do we mean by those? So design principles is that those are like the big guidance. Those are like the vision of those are the vision of when you build an application. An example of that, for example, in the operation is that automate operations, right? So this is a design principle. This is something to follow This is start to frame your way of building your solution to start with the idea of like Microsoft is telling you automate operations. So what does that mean? If you know there is a procedure or a process that always it's replicated and it's always happens in the like in the same procedure, or like always, oh sorry, I think yeah, so happen in the same procedure. So that means it is a candidate for being automated. So I start with this design principle, and then you take it a step further. It's like, okay, so like automate your operation, or like implement monitoring for your application diagnostic. The next step up, which is in this case now, it's the checklist. So what the checklist does is that it turns this guidance, this high-level guidance, into almost like a codified way of turning this guidance into into an implementation. So it takes you to say like, okay, so for you to implement monitoring, you need to like build a Azure Monitor, like build an Azure log spaces. It gives you a set of checklists to make sure that, okay, so if you want to follow this guidance, this design principle, sorry, you need to follow this checklist. And by the way, there's a lot of design principles in every single pillar. And that does not mean you would have to follow each one of them, because every organization is different. Every organization needs and priorities are different, but it's there for you to be inspired by and look at and say like, okay, yes, I can actually automate operations. For example, for a startup, that might not be a big concern because automating operation might take an upfront commitment from them, and they don't have that resource or that access to the tools to actually help them automate their operation. So they might look into a different principle, which is, for example, they might think a lot about cost effective and then maybe trying to save money, or even being scalable. So like if they expect to have a lot of being very popular and then expect to have a spike in traffic. So they think about that as opposed to maybe to a big organization where they have like rigorous processes and make sure that we need to automate it to save money and then save time. And then next step up, now we come to something called trade-off. This is really important because even though these pillars all help build the like a well-architected workload and help you follow best practices, sometimes these pillars contradict each other. So for example, if we think about the pillar of the pillar of operation or pillar of performance and the pillar of cost. So if, for example, let's say that you say, I need to monitor my application and I need to enable application insight. When you enable application insight, that incurs money, and then the saving of logs and then all the events that occur within your application, that storage is also costing you money. So as you could see, now you are like by following the operation pillar, or like you wanted to increase the performance of your application, so you turn on application insight to make sure to get insight into like, is your database being well optimized? You are spending money. So that's where a trade-off that you need to sit and make a decision about. So again, going back to our startup and enterprise application, maybe a startup would not be really concerned at the start with monitoring every single up and down of an application, because it's going to cost them a lot of money. So they might prioritize saving money at the start before they start to introduce more rigorous monitoring and application insight. As for enterprise, the performance of the application, making sure it is well optimized for their user, is much more important, and they're willing to invest in the money and put the money in the application insights, and that's where you have this trade-off. So when you're thinking about implementing the well-architected framework, Microsoft recognized that, and they know that there needs to be some sort of a trade-off when you're following a specific pillar. Next, we go to the recommendation guides. So now that you've picked your design principle, you've gone through the checklist, you decided on your trade-off, now Microsoft takes you through recommendation, which is a set of guidance to actually help you go through and then implement that solution that you started to build. And that is the recommendation guide, is the connection back to another really important resource that Microsoft provides, which is the Azure Architecture Center. So for example, Microsoft has got what they call the Cloud Adoption Framework, the well-architected framework, and then the Azure Architecture Center. The Cloud Adoption Framework is all about the life cycle of your application. So when you're starting to adopt the cloud, you want to migrate to the cloud, move your applications, you want to start to innovate, modernize your applications, modernize, for example, monolithic applications into more microservices applications. That's where you start with the Cloud Adoption Framework. The well-architected framework, as we said here, is all about building your application in a best practices, making sure that you take all the considerations when you are building your application to make sure it is scalable, performant, secure, and so on. The cloud design principle, it's part of the Azure Architecture Center. It is all about solving common challenges, right? So there's a lot of common challenges that organization, whether they're startup or enterprise, as we'll see in a second, face those challenges. And it's because it's common challenges, there is a set of guidance to actually help you to go through it. So the recommendation guide tells you about all sort of links to other guidance to help you build that, but it also connects you, really ties well into the Azure Architecture Center. So in a second now, I'll share my screen to go to the Microsoft Azure Architecture Center, Azure Architecture Well-Architected Framework documentation to show you the new changes. And we'll come back after that to continue our presentation. So if things go well, let me see if I could share my screen. All right. Let me see. Okay. Right. And then how do we get it into the, wait a second. All right. Are you able to see my screen? Are you able to see my screen?
Second layer is what?
Yeah, yes, sir. We are able to see.
Oh, you can? Okay. So can you see the Microsoft Azure Well-Architected Framework?
Yes.
Okay.
Thank you. All right. So this is Microsoft website. And if you actually type in, aka.mswaf, which is Well-Architected Framework, if you hit that, you'll go to the Microsoft Well-Architected Framework. This is the Microsoft documentation site. And again, as you can see here, it talks about the well-architected framework. It talks about also all sort of guidance that you could get from the well-architected framework. And these are the pillars, as we said here. So we've got reliability, security, cost optimization, operational excellence, and then, of course, performance efficiency. So if we click on one of these pillars, now you'll get all the guidance here that you need within that pillar. So for example, as you could see here, you get the design principles, you get the checklist, the trade-off, and the recommendation. And if we click on the security, it's the same pattern: design principle, checklist, trade-off, recommendation. Okay, again with the cost, with the operation, and then performance. So as you could see here, it makes it so much easier for you to actually to navigate. So if you are building your application and you want to follow all the design guides, you will always find them in every single pillar. So if we go to the reliability and then click on some of the design guides, you'll see, for example, it here says like, okay, design for the business. So gather business requirement, focus on intended utility only. If you're building for designing for resilience, so workloads must continue to operate with full or reduced functionality. So this is like, again, as you could see here, this is really big guidance, right? So it is something, it's something memorable, something easy to remember and follow. So the idea is that, okay, so your workload should always continue to operate either in full or reduced functionality. So you build your architecture making sure that if, for example, a specific component of your application fails, that you have a backup component or backup path to actually build around that failure. And then your workloads, and by the way, the workloads could be an application, it could be a virtual machine, it could be even a specific function within your e-commerce site, right? Like, for example, the payment site, or the payment functionality, or the basket for picking up items, right? So this could all be considered a workload. So you're putting backup path to make sure that if one of your functionality fails, it does not take the whole application down. And it takes you through the guidance. For example, okay, distinguish guidance that are critical paths. So like guidance that if these guidance fail, you need to find a way to back it up. And that does not mean that you have to back up every single component within your application, just the most critical ones. And again, so design for recovery, design for operation, and so on and so forth, right? And keeping it simple. Now we go to the checklist. In the checklist, as we said, now we start to codify and then turn these into actionable, understandable. The design principle turns it into something that you could work on. So again, when we said, for example, design for business requirement, and then design that your workload will not fail. And here, the checklist is that, okay, design your workload to align with the business objective, avoid unnecessary complexity or overhead. So that's the guidance, right? That's the checklist. The checklist is saying, this is what you need to follow. When we said that you need your workload to always be working, that's where you say, like, identify and rate the user and system flow. By the way, we'll talk a little bit about later in what is a user and a system flow. So a user flow is like the flow of action that a user of your application will go through. So for example, if you imagine the e-commerce site, the user will pick up an item, put it in the basket, go to the checkout, pay the money. That's the user flow. And then part of that, you start to identify functionality within your application. So like the basket of your application, that is a critical component, because if that fails, that means that you're not going to get money, right? The system flow on the other side is that when you start to pay the money, for example, the back-end system that goes and authenticates, does this guy has got money in his credit card to pay for this item? Can I actually ship it to his location? This is called system flow. And again, for example, the link back to a bank is considered critical. You need to design reliability around that, okay? The next step here is the trade-off. So now, again, that's the beauty of this documentation, the new version, is that now it's designed so to be followed so easily. So for example, when they talk about trade-off, when it comes to reliability, they come and bring every other pillar within the well-architected framework, and they put it in this page for you to actually compare. So for example, as you'd see here, there's reliability with security, there is reliability with cost, there's reliability with operation, and then finally reliability with performance, right? So this makes it so much easier for you as a person building an application on top of Microsoft Azure to actually understand the impact of your decisions. So let's take an example of trade-off, reliability trade-offs with security. So what it says here is that, reliability is often obtained by replication. So like if you've got a component within your application, you need to replicate it in multiple geographical regions and so on and so forth. And also disaster recovery is also based on backup. The trade-off here is that because that you are having multiple backups and multiple replicas of your application, now the surface area of attack is increasing. What that means is that if you say, for example, I've got a copy of my application in Australia, a copy of my application in India, so now I have two places that an attacker could actually attack, right? So now the surface area for attack on my application is increasing. So that's a trade-off between reliability and security. So when you take make that decision, you need to be conscious. The more replicas, the more backup you have, the more places that you could be attacked, and that is increasing the surface of the attack. And again, of course, it goes to cost. The more you replicate, the more you back up, the more it costs you, right? The next section here, it goes to recommendation. And as we said here, that's where we connect back all these design principles, the checklist, the trade-offs, back to guidance and recommendation to common problems like the cloud design patterns and the Azure Architecture Center. So a lot of the recommendation here is connected back either to a specific documentation deep within Microsoft documentation or to a link back to an Azure Architecture Center. So for example, in here in reliability, it talks about something called like the ambassador or like back end for front end. So let's take the ambassador. What is the ambassador? So as soon as I click on the ambassador, you notice that we move to some other document, some other location in the document, which is now we are in the Azure Architecture Center. So we left the Azure Well Architected Framework and then moved to the Azure Architecture Center. And what the ambassador means, it's in simple terms, is that this is your application code, which is your e-commerce site. This is the remote service, could be the bank. And in here, you need to build something called the ambassador. What the ambassador does is that instead of you, for example, let's say the connection to the bank is failing, you'd have to put some sort of a retry, right? And then the retry goes and check, is the bank API up again, or is like replying? If not, to try again. But if you keep on trying again and again, you need to have some sort of a circuit breaking so that you will not be stuck in a loop. And of course, you need to have some sort of monitoring, you need to have some sort of security. This is all called proxy to handle. So this ambassador is doing all this for you. The reason for that is that you don't need to build all this functionality into your code. So like if you're building an e-commerce, it's super hard for you to actually go and build a retry circuit breaker monitoring. So instead, you could use something like the Azure API management. So like Azure API Manager or management could just be the ambassador in this case. It will be talking to the bank in the backend. So what it says here is that, for example, how does that increase the reliability? It talks here about network communication. It talks here about buffering. It talks here about retry. What is this saying is that for you to increase the reliability of your application, you have this ambassador built within your application that is always talking back to whatever remote service. Okay. So, and again, it moves on to things like simplicity and efficiency. These are more and more guidelines to help with your reliability. It even talks about trade-off. And for example, if we go to the checklist here, if you notice here, it says like RE01 talks about reliability. If we go to the checklist where I didn't mention it here at the time, was going through the documentation, is that as you could see here, this is the same thing, right? So when we go through the checklist, it is actually referencing those recommendations in here. So for example, when it says like identify user flow and then system flow, if you click on this, as you could see here, it takes you within the critical flow. And critical flow, it means like a specific flow of application, of user and system flows, as we said, when a user buys from your e-commerce site, or when a user when the system is trying to authenticate back to the bank. So, and that of course continues again when it comes to security with, for example, design principles. It gives you things like to follow for in this here, verify explicitly, right? Again, it's very easy to understand, very easy to remember. Use least privilege access. Always do that. Always follow that. By default, give people least privilege. If they need more, then you'll elevate their privilege. And then assume breach. Assume breach, which is like, okay, what happens if my application is being breached? And then that's another design principle. You go through the checklist again. How do you do that? And then trade-offs, again, between reliability and security, so on and so forth. Again, with recommendation, cloud design patterns, and then so on and so forth. And this again goes to cost, operation excellence, and then performance. There's also some other thing here. So like there are specific workload that Microsoft decided to put inside what's called like a workload. So for example, for Azure Virtual Desktop, there's a complete guidance, and specifically for the Azure Virtual Desktop, this here talks about the design principles again, and again, it's similar guidance when it comes to reliability, cost optimization. There is another workload that is really interesting, the hybrid model, which talks about, for example, the Microsoft Azure Arc, and so on and so forth, and how to build a hybrid model. Again, takes you through all these pillars. The other section that I wanted to show you here today is the service guide. That one is I really like, is that this one talks about every single service within Microsoft Azure and then applies the well-architected framework around it. It doesn't matter if it's an application around a solution. It's more about what that specific service require, or like how to build that service following the Azure well-architected framework. So for example, here I was looking for my favorite topic, of course, which is networking. The reliability of your network. So for example, you need to, when you design your network, always make sure that there's no overlapping IP addresses. Make sure that you need to have some virtual network space. You need to resize or resizing of paired virtual networks, like subnets can be delegated, and so on and so forth, and then gives you a set of checklists. Use Azure DDoS, use IP addresses from like a private IP addresses, use for example, if you've got use network virtual appliance, and so on and so forth, and then it comes to operational excellence. And for the virtual network, they give guidance on what really matter, the reliability and operations. Not every service needs specific guidance on every single domain, right? We've got, of course, the Azure Kubernetes service, and then so on and so forth. The final section, I think, here is what they call like the cross-cutting. Cross-cutting is that the first thing is called health modeling. So it's all about checking the health of your application, all about understanding how performant and how it's like scalable your application is. All about the health of your application. And again, this one, the implementation recommendation called the review assessment. That's the whole, it's like a set of questions and guidelines to help you take existing workloads. So all what we're talking about, it was about onboarding new applications. But what happens if you already have an application or a workload, like an e-commerce site that you've built on Microsoft Azure? So does that mean you can't follow this guidance? Actually, you can. And that's what they have created here, which is called the Azure Well Architected Review. It's it's an assessment question that says like, okay, have you considered cost? Have you had some monitoring? Did you put some like a web application firewall or whatever for cost, for security? And are you authenticating and authorizing? Do you have MFAs? So on and so forth. And then that's the flows that I was talking about, the user flow and then the system flow. So for example, it says here, you start by understanding the flow, understanding the prerequisite, understanding the business flow. This ties in really well with the design thinking that we talked about earlier in the session. Okay. And then document the flow, define it, design it, develop it, and then optimize. It's very similar. These are multiple ideas to do the same thing. Actually, not the same thing, sorry. For example, it says here like purchase the ticket, authenticate, authorize. These are the flows within the application. And I think one final thing I wanted to show you here before I go back to our session, this is the architecture, Solution Architect Fundamental. This is another beautiful guidance to actually help you if you want to become a solution architect. So this takes you like, how do you decide what you need to know, like your cloud design patterns. You need to be forward thinking. You need to design for supportability. So like you not build an application and then the application becomes a nightmare to support. And then again here, what type of deliverables? So like things like the solution architect checklist, the design diagrams, and so on and so forth. So I'll go back to here and then say, I don't know how do we stop sharing? Remove from the stage. And then, yep, thank you so much. Yeah, so that's like a lot to fathom now. It's a lot of topics that we talked about. So we started with the design thinking. We started with our application and then business requirement. We learned all about the new Azure Well Architected framework, all the pillars, all the guidance, design principles, the checklist, the trade-off, the recommendation, the cloud design patterns. Now, what I want to go back to is that how do we apply that to our application? So we said that the business wanted us to build this application, and then you went in and you collected all the technical data. How do you turn that into an ideation? So like some sort of creating ideas to build your solution. So so you went. So what we're doing here is that we imagine that we went back, we understand all the technical requirement, and we have identified two possible solutions within Microsoft Azure that could actually help us build this solution. So so for example, in here we identified the Azure App Service, and then we have identified the Azure Container Apps. These are two candidates for us to build our application on it. And then we have multiple aspects that we need to consider when we are picking which one of those services could actually fit. So when it comes to deployment, Azure App Services could work with just the code. So you've got the code and then you just host it there and you don't need a container. Or if you have your own container, you could do that. Azure Container Apps requires a container. Scalability, Azure App Services scales both horizontally and vertically, so you could have multiple instances if it is horizontally, and you could scale the resources, the CPU and memory when it is vertically. Azure Container Apps can scale horizontally only, but it can also scale by event-driven. So like if an event happens, you could have an event happen means like the Azure Container Apps is give you a very granular setup of scalability, because it could trigger things like if you have a specific amount of CPU or like a specific amount of calls to your website. Pricing, the Azure App Service is a per app service plan. What that means is that, for example, you go and then buy a service tier for your web app, and then that tier gives you specific memory, specific CPU, and specific set of features, and then you pay for that service plan in a monthly basis or whatever. But that money you pay whether you use your app or not, right? So like it's fixed amount, it is predictable. For the Azure Container Apps, because it is a serverless application, which Azure for the context, Azure Container Apps is actually a solution that Microsoft built on top of Kubernetes. So it is Kubernetes underneath, but you don't need to access the underlying Kubernetes. So so it's all wrapped, it's all contained and configured by Microsoft. You pay for that because it's a serverless. You pay only when you use it. So when you use it, you pay for it. When you don't use it, you don't pay. So that's what's called a per consumption. And again, for customization, Azure App Services give you some limited customization because it comes almost like a set solution. The Azure Container Apps is very flexible and you could customize it a lot. And then manageability, it's easier to manage an Azure App Service compared to Azure Container Apps because it's much more powerful, much more flexible. So with these two solutions, now we go back and use the pillars, right? So like we just went through the pillars, we understand how to use them. Now let's go and say like, okay, when it comes to reliability, security, cost optimization, performance efficiency, and then operational excellence, how do these two solutions factor in? And of course, in the real life, it's not just like picking two technologies or two services. It's much bigger. But for the sake of argument here, we're just picking between Azure App Services and Azure Container Apps because there's like multi-tier apps, there's like your database tier, your business logic. There is so many things that goes into a solution than just picking two solutions within services within Microsoft Azure. For reliability, again, so quickly going through it because for the time and I need to address some of the questions. Reliability, so Azure App Services has got some built-in load balancing and auto-scaling. Azure Container Apps advanced auto-scaling and has also event-driven. Security, Azure App Services come with a managed SSL, which is a really good feature if you're building a web app, and also easy to authenticate integration. Azure Container Apps have like much more granular network policies, have got managed identities. It's much more, provide you with much more flexibility when it comes to security. Cost effective, it's the price for Azure App Services is predictable, but of course you get shared resources. So like if you buy an app service plan and then that is hosted, say, on a server, of course you don't see all the details, but that server has got multiple users on it. So if someone is using those resources, you will be sharing those resources with them. For the container apps, it is per execution. Again, as we said, it's serverless. For performance, the Azure App Services is optimized for web workload. As for the container apps, it's really highly customizable. It is used to build microservices application. For operational excellence, it is simplified management for when it comes to Azure App Services. It got built-in CI/CD. For Azure Container Apps, it's following Kubernetes-like operations. So like you could use all the things like GitOps and so on and so forth. It is advanced deployment strategies. So which one did we pick? We ended up, of course, picking the Azure App Services because it fits what we want. So this is just an example of an Azure App Services architecture. It is very similar and realistic to like when you pick a solution, it contains all sort of like monitoring, security, identity, database, and business logic, authentication, and so on and so forth. So why did we pick it up? So based on our understanding, based on our using of the Azure well-architected framework, we find that for reliability, it meets the 99.99%. It contains load balancing. For security, it gives me simplified compliance, built-in authentication. It's very predictable when it comes to cost. It is easy. It is already optimized for web app, giving you the best performance possible. It also supports your traffic spikes. In operation, it's very low on complexity and suits your current team skill. So as an architect or as a person building a solution, you always think about your team that's going to maintain this one, the operation team. So if you want them to run Azure Container Apps, they need to understand a little bit about running Kubernetes-like operation. So considering the team skill is also important. And yeah. So that takes us back to the conclusion. So what have we learned? So design thinking helps us ideate, helps us refine ideas, helps us turn system requirements into solutions. Well-architected framework turn these ideas into solutions, and that you could build it in a best practices way. And when you want the well-architected framework, and the well-architected framework specifically is for existing workloads and for new workloads. And if you want to run a well-architected framework assessment for continuous improvement, actually, I'd like to take a chance to answer one of the questions here. The question is typically how long does it take to run a well-architected framework assessment, and how frequent we should run it against the subscription. So the well-architected framework is actually, it's a workload based. It's not about the complete subscription, right? And then the well-architected framework is a set of questions that based on your understanding of the environment, you could run it yourself, or you could have an expert help you do that. So you take the question is like, okay, so when it comes to security, have you done this? How do you define your security practices? And it gives you a set of questions. It takes you through all these questions. When you finish up the questions and hit submit, it gives you a score, saying like, okay, you scored on a scale of 0 to 100, something, let's say 50, 70, and tells you where each specific question, what type of, which specific domains you need to address. So it's mostly based on the person running the assessment and also the stakeholders within your organization, the employee, the person maintaining the uh, um, the solution. So based on that, it is it takes a while, and it depends on how do you want to run it. And of course, for resources, as we said, it's if you want to visit up the Azure Well Architected Framework, it's aka.ms /WAF, Well Architected Framework, and of course, the Azure Architecture Center. So yeah, back to you, Kishore. Thank you.
Okay. So if anyone have any more questions, this will be the right time to ask.
Yep.
Okay. So while people are taking time for it, so coming to the pricing constraint alone, which would be better actually? Myself, like I've been working with container apps recently in my company, and I feel like it's pretty easy for me to cope up with, and I haven't had much experience working with Azure App Service. So pricing wise, which should you prefer? Like, it's app service going to cost us more or container apps?
There is, and by the way, if you're building applications and if you want to know like the price of the workloads or like the service that you're building, there's an application that there's an extension. I think it's called Azure Infra Cost or something like that. It is about it's using Terraform. So like if you build an application using Terraform within VS Code, it actually gives you the cost of running the cost of if you build the application. It tells you how much it's going to cost. And I think there's a similar tool for Azure Bicep. I can't remember the name, but I'm pretty sure there is another tool for Azure Bicep. So if you're building using infrastructure as code, you would find how much the cost of your application. If you're building it using the portal, if you go to the cost center, you will find cost of your applications. And again, to answer your question about Azure Container Apps, so like if you know that you need the flexibility, if you know that you need the power of Azure Container Apps, and then you know that it's not going to be running all the time. So like it's not, for example, because Azure Container Apps in the end, it's a serverless app. And it runs, it does some business logic for you. And then if you don't use it, it scales up and down and could even scale down to zero. So if you know that this, for example, only occurs on the e-commerce site, you've got some logic and you need the Azure Container Apps, and then when the user clicks on buy, or like when the user clicks on the add something to a basket, of course it's a simplified solution, example. Maybe that's the only time when your container app's running, and then when it doesn't not needed, it's shut down. So maybe that's a good way of using Azure Container App if you need the power but still don't want to spend a lot on the money. But if you know that you need your application to always be running, you don't need all the flexibility, all the power of the Azure Container App, then Azure App Services is a much better bet. And it's you could even just host your code there. You don't need to use a container. If you have a specific container, application logic that you build it into a container, you could do that.
Okay, that makes sense.
Yep.
Thank you for that.
No worries, mate.
So, do any of you have any other questions? Like, you could feel free to post it in the chat. Not, I think we can go ahead and this. So, thank you, Ahmed, for that wonderful explanation on the container apps as well as the architecting
Thank you.
workload. And we truly appreciate your time and your expertise and sharing your knowledge with us. So,
thank you so much.
also,
Thank you. I hope it was
you
useful. Thank you.
Yeah, and you talking about content apps is really going to be helpful for our members, because actually the next session which Santosh is going to be talking is about the security using content application. So
Oh, wow.
everyone,
Yeah.
so everyone got an introduction to content apps, and it's going to be useful for them while they attend the next session.
That's
So,
good. That is good. That is
okay,
awesome.
thank you once
Yeah.
again, and
Thank you for having me.
everyone,
Thank you.
yeah. So to everyone, please do post your feedback and your suggestions in our social media platforms. So we are mostly active in our LinkedIn as well as Meetup. and also our Twitter handles. So you could also reach out to Ahmed using his LinkedIn handle. We have shared that in the description. You could also connect with them.
Yeah, you can reach out to me
with,
on LinkedIn and on Twitter. Connect, and I'm happy to connect. So yeah, please do.
Yeah. Okay. Thank you once again, and yeah, take care, everyone.
Thank you so much,
Yeah.
mate. Appreciate it. Thank you.
Bye.
See you.